Welcome to Mrs. Mahoney's podcast. This is our fourth and final one in our Unit 11 on acids and bases. I'm at the top of page 11, and we're going to be talking about a specific, well, actually still a neutralization reaction. So it's a reaction between an acid and a base, but it's going to be very controlled. So up there we have acid-base titrations. Write down this definition somewhere right across the top. What is a titration? It's a controlled addition, and we have a measurement of the amount of a solution that reacts with an unknown solution. This is just like we did it on the gizmo looking at it. I know the concentration of the acid, and if I know how much of the acid I used and how much of a base, I can find out the concentration of my unknown base by realizing what happens in an acid-base reaction. So our titrations, there's different ones. The ones we're going to look at, it's a very controlled reaction. Titrations are very controlled reactions. We're going to only be looking at pretty much the acid-base reactions. You use it to, again, identify an unknown concentration. So just some words we're going to be using. The unknown, hey, it is what it sounds like. That is going to be the acid or the base. It can be either, but it's the one where you do not know what the concentration is, hence it is unknown. That's the one you do not know, you're trying to figure out. The standard solution is the one you do know the concentration of. So if I have two things, I have to know what the concentration of one is. And so as long as I know that, I can use that to find the answer to the other one. Okay, the transition interval is going to be a pH range which an indicator changes colors. Let's kind of look what's happening when you have an acid base. So this is my pH. If I'm starting with an acid, I'm going to start with a low pH, and then you're going to add a base. And as you add that base in, it's going to climb, climb, climb. Then what happens here, you reach kind of this midpoint right here. This is what I want, is where I have my hydroxide and my hydronium. Or if I started with my hydronium and my hydroxide are equal. Well, with a transition interval, that's where you have to find the indicator that changes over a certain pH, because what you need to do is find an indicator that's going to change the color. Okay, so the endpoint is what we're going to look for. This is like an endpoint, and what happens is it's going to change. I have an indicator of an indicator. So let's look in there. What is an indicator? An indicator is just a chemical that changes color in a acid-base reaction. It changes color with a change in the pH. So write that down. What is an indicator? It is a chemical that will change color when the pH changes. We're going to use phenolphthalein. If you looked in the gizmo, they had different indicators that change depending on this transition interval. And this all went to do if I'm doing a strong acid, strong base, strong acid, weak base, weak acid, that's going to change, and you have to use the indicators. I'll pretty much do this when you start in AP Chem or in college chemistry. A lot of times you have to pick the right one to use. Okay, so let's look what happens when we get that endpoint. So if it's neutralized, so let's look and see what we know when we reach this endpoint. When we said it's now neutralized, what does that neutralize means? That means that my hydrogen concentration is equal to my hydroxide concentration. So let's look mathematically what that means. We're going to use molarity, which is moles over liters. Okay, so this would say then my concentration is going to be the same. What does this mean? That then my moles are the same, that I have the same amount of moles of hydroxide and hydronium. Well, let's rearrange this. How do I find moles? Moles is equal to your molarity times your liters. Well, haven't we seen this before? Maybe just a different version. Moles is molarity times volume. Let's plug this in over here. So if I know moles for my acid, this would be the molarity of the acid times your volume of the acid. How about for the hydroxide? It's going to be equal to the moles of the molarity of the base times the volume of the base. This looks very similar to the M1V1 equals M2V2 because it is the same concept that the moles are equal at that point. Okay, so let's look at this. I still need to balance the equation because I need to see if this is a 1-to-1 ratio when I'm looking at this. So what do I know as I'm looking at this? I have potassium hydroxide is mixed with hydrobromic acid. Both are solutions. What do I get? It's a neutralization, so I know I get water and potassium bromide. Okay, everything is balanced. It's a 1-to-1. Okay, so now I'm going to go up here and start listing out what I know. So I have 15 milliliter sample of a 0.215 potassium hydroxide. This potassium hydroxide is my base. So what do I know? I know my volume of my base, and I know my concentration of my base, 0.215. Okay, keep reading. Required 31.2 of my acid, so that's my volume. And it says, okay, what's the concentration? That's my unknown concentration is what I'm looking for. So what am I going to do? Plug it in up here. This is the molarity of the acid times the volume of the acid. So let's know what I know. Do I know my concentration, molarity of the acid? No. That's my unknown. What was my volume of my acid? 31.2 milliliters. Okay, what was my molarity of the base? 0.215. How much of that did I use? 15.5 milliliters. So then it just becomes the easy math, 0.215 times 15.5 divided by 31.2. Notice my volumes, because I'm doing the M1V1 equals M2V2, I can leave them in milliliters as long as they're the same. So when I divide that out, three significant figures, 0.107 molar is my concentration. Okay, that's pretty much when you're looking at it with a 1-to-1, M1V1 equals M2V2. Okay, what if it's not always an M1V1? Let's kind of look at what's happening down here. So if I have aqueous sulfuric acid, H2SO4, and I'm reacting it with some lithium hydroxide, what do I get? Well, I know I get water and lithium sulfate. So then I have to make sure it's balanced to 2. Okay, same thing though, I'm going to list what I have. I have 17.6 milliliters of sulfuric acid, so that means that's my volume of my acid, 17.6 milliliters. Okay, I have my volume of my base, I know, because it's 27.4 milliliters. And the molarity of the base is 0.0165 molar. Okay, and it's asked what is the molarity, so I'm looking for the molarity of the acid is my unknown. Okay, well the one thing that we're looking at here is it's not a 1-to-1. So if I was writing these out just of moles, let's look at this mole ratio. So this is saying for the moles of, let's say, our base, let's just kind of compare, what does that say for every 1 of the acid, 2 of the base? So that really means I'm going to take these moles of my base and divide them by a half. So whatever my moles of base, I would divide them by half would equal my moles of acid. So 1/2 the amount of my acid for my moles of base. I don't like dealing with a half, so let's just flip that then. That means then, instead of taking my moles of base and dividing it by half, when I write still MAVA equals the molarity of the base, the volume of the base, okay, I can divide this by 2. But I don't like dealing with fractions, so it says dividing by 2. Let's move the 2 to the other side. So I have this divided by 2. The way I'm going to write it then is 2 times the opposite. So wherever this is needing, you can either, if you want to say this is just divide by 2 and then do the math and multiply it over, or if you want to go ahead and do that step and realize that 2 goes to the opposite because of this stoichiometry here. is y, the reason of the opposite. This is what the overall formula is going to look like. Now then I can just plug in chug of what I'm going to do. So 2 to my molarity of the acid, that's my unknown. Do I know my volume of my acid? Yes. 17.6. Molarity of the base, that was 0.0165. And what's the volume? How much of that base do I have? 27.4 milliliters. So now the math, going to multiply these. Now make sure when you divide this, so 2 times 17.6, and then that number gets divided by both. So doing that, I'm going to have, I will have 0.0128 molar. Okay, let's start 3. So I have calcium hydroxide plus, what am I doing? Chloric acid, HClO3. Again, these are both solutions, both aqueous. What do I get? Calcium chlorate, which is aqueous, and water. Oops, I already started balancing it, and I knew because of my charges that I'm going to have to balance it. So look at this time. I'm going to have a 2 in front of my acid, so that means when I write it, Va, it's going to be 2 of the base. Okay, finish this problem. What you need to do when you finish this problem, you get 22.5 milliliters, but look at our sig figs. We can only have 2, so I would round this then to 23 milliliters. Keep working it, see if you get that answer, and this is again what we'll be working on Monday, but we'll also need this for the lab that we're doing in class. I will see you tomorrow.